when we put all our information together, we're going to have something that looks like this. We're going to have a graph of force in millimeters versus acceleration in centimeters per second squared. We're going to have several points down here in this corner of the graph. Remember that the millimeters aren't measured from zero, so that we don't expect the force as measured in millimeters to be zero when the acceleration is zero. But we're going to have our data points here corresponding to accelerations up to maybe 100 centimeters per second or so. Remember, we don't want to take the ramp slope over about 0.1. And then we're going to fit a straight line to that data. Now, if the force changes with the acceleration according to this straight line, then any difference in force will be accompanied by a difference in the acceleration of the falling cart. Now let's construct a triangle where this side is the difference between no force. Okay, this distance represents a difference between no force and the total force on the cart as suspended just under the influence of gravity, not on the incline, but as we had it suspended when we measured how much stretch would correspond to the force required to hold up the car against gravity. Okay, so we let this side be that force. Now, if the force changes by this much, how much does the acceleration change? The graph is going to tell us how much acceleration change there is between no force and whatever force gravity exerts on the car. We'll be able to use the slope of this graph to determine what that acceleration is. The force represented by this line here again represents the force of gravity on the car. That's also called the weight. So we call this the weight stretch, and that's going to be our delta F. The difference between no force on the cart and gravity force on the cart. That's going to be the length here. That's going to be used to predict the acceleration of the falling cart. And this will be the acceleration that the cart has if we simply drop it and allow it to accelerate freely toward the floor.